Hello world. This is an engine cover from a Yamaha XS650 motorcycle, but it has a little problem here. A previous owner has broken this bolt mounting hole. I have a good cover over here. This is what it's supposed to look like, and this is what I have. This particular bolt hole is a little bit unusual in that it accepts a locating dowel, like so, and the locating dowel allows it to align correctly when it's placed into the engine case. Now, there's a couple ways this could be repaired. One is with aluminum welding, but I am not a welder, and I'm going to be trying to do this repair by myself at home. I also want to say I'm going to try to do this without a lot of fancy equipment. I'm not a machinist. I have some pretty basic tools, but nothing really fancy. So to begin, what I'm going to try to do here, is I'm going to try to get this edge going along from here to here perfectly straight. You can see with this straight edge that I've got here, I've got a high point right there. So I want to knock that high point down so that I have a perfectly flat surface here that I can scab onto. There's also, you can see there's a little casting ridge right here. So my straight edge also does not fit flat this way. So I want to try to get it flat in both axes. And again, I'm going to try to, once that's done, I'm going to scab a repair onto this. So let's get started. What I'm using here is an 8-inch by 3-inch expanding rubber drum with a 100 grit silicon carbide sanding belt on it. The sanding belt is 3 inches wide by 25 and 7/32 inches long. This expanding 3-inch by 8-inch rubber drum is a really nice tool to have. It's a little bit expensive, but very versatile, and I use it all the time. The motor that I'm using, I've had for about 30 years, and it's the same motor that I use with my buffing wheels and with my wire wheels. Here is the result. This came out way better than I was expecting. It's not perfect, but it doesn't need to be perfect. I've got a very good straight edge in this direction, and I've got a very good straight edge in this direction. Pretty good. I've got a couple of voids, one right here and one right here. They are insignificant for the way this repair is going to be made. I've got this piece of very thick aluminum. It's just under 1/4 inch, and I think it's just thick enough to give me enough material to make the little, circular area that I need around the broken hole. The next step of this repair is going to be cutting a little scab, which I then will attach to the flattened surface here. I've taken my aluminum plate, and using a hacksaw, I've cut off a small piece which I'm going to use for my scab, and I've securely attached it to this piece of wood so that I can drill holes in it in my drill press. And I've drilled a pilot hole here, and I've drilled a pilot hole here. Using the pilot holes that I drilled in the scab as drill guides, I am now extending the pilot holes into the cover. The next step will be to grind out the area where the locating dowel goes. This will be done using a Dremel and a variety of burrs, and I also have a very small drum sander. These pins allow me to very quickly remove the scab while I carve it, which is all going to be trial and error. So that there's going to be lots and lots of repeated fitting and removing. I don't want to do any carving at all with it attached because I don't want it to slip and remove material from the cover. I only want to be removing material from the scab. So again, I've got these, the pins are nice because I can very quickly slide this on and off as I repeatedly test while I carve my hole using my burrs. I am using a tungsten carbide burr to carve the scab. The running water keeps the burr and the work cool and removes the debris. The rotary tool is plugged into a GFI circuit breaker so that I don't electrocute myself. I've reached a point in my grinding where I'm beginning to get close. Do a test fit here. You can see from the rocking I have a little ways to go, but I'm fairly close. So what I'm going to begin doing is I'm going to take some Prussian blue and put a very thin coat on the locating dowel. Then test the fit again. And I can see where my high spots are on the scab. After much testing with the Prussian blue and then grinding and then retesting, I'm pretty happy with where I'm at right now. I've got a pretty snug locating dowel, and this is what my grinding looks like. I've got a pretty good fit here. This, of course, this goes at an angle, as you can see, but like I say, it's a pretty nice fit. I'm pretty happy with it. I have returned the scab to the holding jig which I made earlier, and I am now ready to enlarge my pilot holes to their finished size. I am enlarging the holes, the pilot holes that I earlier made in the case cover. My scab is now attached to the cover. Here it's attached with a screw and nut, and here it's attached with a screw which is screwed into a threaded hole. So I had this reinforcing web in the way, which meant that I couldn't use a nut like I did over here. So instead I threaded the case. I tried to extend the threads into this supporting web here. That didn't quite work out, but nonetheless, those are M5 screws, one screw threaded into the case, and one screw held on with a nut. What's left to do now, this scab is higher than the cover is. So I need to come back and cut down the high part of the scab here. And then the other thing I need to do is the bolt hole needs to be enlarged so I can actually get a bolt into it, like so. Back to the expanding rubber drum, I started off with 100 grit, which is what you see here. I quickly realized it wasn't aggressive enough, and I changed to 36 grit, which is almost like aquarium gravel. I spent a lot of time on the 36 grit using water from a spray bottle to keep the work cool. Then I switched back to the 100 grit, did a little fine tuning, and finally I went to 320 grit, which was almost like a polish. This is the result of my edge grinding. I think it came out pretty well. You can see that I have a nice straight edge. The flat plane of the gasket surface on the cover is interrupted by this protruding pin. So I have taken a board and drilled a hole in it, which that pin fits into, and now my cover sits perfectly flat. This means that the bolt holes are now perfectly true and plumb, and it means that I can take my cover and put it in my drill press, and using a burr bit I can finish opening up my bolt hole. When I was doing this, it occurred to me that this surface here is also perfectly flat and true and plumb. So I could have attached my cover and secured it to a similar board, and now my dowel hole would have been perfectly plumb and true. And I could have done the grinding of the dowel hole also in my drill press using a burr bit, which would have been a whole lot easier than the way I did it, using the Dremel and holding everything by hand. At this point, if I wanted to, I could call the repair done. However, there is one small bit of fine-tuning that I would like to do. This surface here that the shoulder of the bolt head is going to sit on is not even. On the cover, it's been gouged and is angled, and on the scab also does not sit plumb, so it's also angled. So I want to find a way to level that. One way to fix this would be to mix up some JB Weld, dab it on my uneven shoulder surface here, take a washer and set it on the JB weld, and then take a bolt and with a nut and washer on the back side of the bolt, make sure that the bolt sets level while the JB weld sets. But I'm going to first try a different method. The very best way to level my uneven shoulder surface would be with a piloted counter bore, which is a tool specifically made for this very purpose. Another way I could do it would be with a silicon carbide end cut burr. However, I don't have either one of those tools. A inexpensive one on eBay of either one costs about $15, and the whole point of this repair is to make it with tools and materials that I have on hand without spending any money. So instead of the end cut burr or the piloted counter bore, I'm going to try using these Dremel type grinder bits in my drill press. And specifically, I have this one here which is black, and the black supposedly is made of silicon carbide, and it's supposed to work specifically on aluminum. Your other type of grinders, like the red or the brown, these will load up with aluminum very quickly and become useless. However, when you buy these kits of bits, and all these Dremel accessories, you get these little grinding stones, which I believe, if I was to use a grinder like this in the drill press, when it was loaded up, I could then grind it into this black, which I assume is silicon carbide block, which ought to get the aluminum out and level it once again. So anyways, I'm going to do a little bit of experimenting with these bits and see if I can't get my area here level. Sure enough, the brown grinder on the right, which is aluminum oxide, quickly loaded up with aluminum particles and became useless. I tried cleaning the brown grinder with the black silicon carbide block, but that did not work. The black grinder on the left, which is silicon carbide, was too small, and the silicon carbide grinder in the middle was too big, but I think I have a way of fixing that too big grinder in the middle. I've chucked up the grinder into my drill motor, and I'm going to run it along my expanding rubber drum, which has a 36 grit sanding belt on it. This worked great and made very quick work of reducing the diameter of the black silicon carbide grinder. And here's my modified reduced diameter grinder. And here's the result after using the grinder, which I just modified. With the bolt shoulder contact area now flat and level, I have decided that my repair is finished. There is a tiny little missing piece of material here, which is part of the original damage. However, I think that if I use a washer when I use my bolt, I will be just fine. My original plan was to fill in this void here, and there are a couple of hidden voids where the scab meets the cover. I was going to originally fill those in with JB Weld. However, I decided that's not really necessary. It would just be cosmetic, and this isn't really a cosmetic repair that I've done. So I'm not going to spend the time doing that. I will mention that there's what looks like damage right here. That's actually a semicircular void, which is part of the casting, which allows water to escape should water ever get behind the cover. The gasket that goes on this is designed to keep water out, not oil in. This is a dry cover that goes over the stator. Here is the finished cover on my award-winning 1973 Yamaha TX650, also known as the Super Rust Bucket. If you are low and close, you can easily see the repair on the bottom of the cover. But if you are standing or are a few feet away, it's not too obvious. The Super Rust Bucket is a multiple award winner in the rat bike category. It features a working Kryptonics skateboard. The front wheels fit perfectly into the stock tool tray, and the rear of the skateboard is secured to the seat hoop with a U-bolt and 2 wing nuts, so the board goes on or off in about 30 seconds. The exhaust features a removable block-off plate for drag strip use and a long pipe for street use. The cover that I repaired will be modified to accept a hydraulic clutch slave cylinder. I didn't want to modify a perfectly good cover, which is why I made the repair to this broken one. I am converting from the stock cable-operated clutch to a hydraulic clutch, and that mod will be my next video. That about covers it. Thanks for watching. Hey, by the way, check out this cool 40-year-old vintage pinstriping. All right, see you next time.